um, for you to have the some main criteria of the parametric and non-parametric. So we have the most important thing is the distributions. So in parametrics, the data will follow normal distributions, and it is arbitrary in non-parametric test. It means that it doesn't follow the normal distributions. And I will show you how to check if data follow the normal distribution or not. Next one, the second important point is the parametric will be used for interval data. And interval data, it means the data is present in number. And non-parametric tests will be used for nominal data, like numbers. All right? Okay, so those are the two important things for the parametric and non-parametrics. And in the parametric test, it involves the mean populations. You see already here. So in parametrics, it involves the mean of populations, and in non-parametric, it involves the median value. What else? It has a strong assumption in parametrics. You see here, it has strong assumptions. And in non-parametrics, it doesn't have the assumptions. Some examples. Okay. So the advantage and disadvantage of non-parametric test. The non-parametric test, the advantage is easy to compute. Yeah. Actually, all of them are easy to compute. It's not difficult. So it doesn't need the population, the involved population parameter like mean or variance. We think about the median, but it's not population. It's not a mean or variance in non-parametric test. The results may be as exact as parametric procedures. Okay, so the parametric test, the result is okay. You will not have any problem if you use the non-parametric test to reach the conclusion. This is okay. It depends only on the data distributions and data distribution and the type of data is in interval or nominal. The disadvantage of the non-parametric test may waste information. Difficult to compute by hand for large samples. So for small sample, I will show you an examples. You see, it's easy to compute non-parametric test for the small samples. However, for the big sample, it will have problems. It's more complicated. Not difficult, but it's more complicated. All right. So first, we will go into t-test and z-test, which belong to the parametric test. The main difference between t-test and z-test, please pay attention here. So you see, t-test apply for small sample, z-test apply for larger samples. So with the small sample and larger samples, we consider if the sample has around smaller than 30 observations. So it is small samples, and if it's bigger than 30, we consider it as a big sample, large sample. In t-test, the variance is unknown, and z-test variance known. Okay. t-test and z-test are used to compare the mean. How the mean of two data sets differ from each other. So you will compare means. It depends on the sample, the size of sample, and the variant of sample. So you will choose t-test or z-test. We go more detail. This is the equation of t-test and z-test for one samples. t-test and z-test also used to compare the mean between two samples, and it also used to compare the mean to check an hypothesis from only one samples. So this is the equation for one samples. And you can show example for more detail. The organs, we know the population variance. We use that test. The population size is large. So it means that the observation bigger than 30. Right? In the case you have sample smaller than 30, and you do not know the population variance, so you must use the t-test. Alright, so the main difference here is population variance, known or unknowns, and the size of the populations. Truly size z-test or t-test. Okay. Here is the equation to calculate the z-test. Score equal, you see, so for the it equals sample mean minus population mean divide by population standard divide root square of sample size. Okay. This is the equations. Sample mean minus population mean divide by population standard. The sigma is population standard and divide by root square of the sample size. You see on examples. Look at the examples. The average test score for anti-scroll is 75. Okay, anti-scroll. It means that, what is this? The average test score for an anti-scroll is 75. So what is this?
It's mean
What is
population.
Okay, it's mean of population. So you have mean equals 75. Next one. The standard deviation of a random sample of 40 students is 10. So what is 40 here?
Sample size.
Yeah, it's sample size. And what is 10 here?
Yeah, it's a standard deviation.
It's standard deviation. It's standard deviation of the sample. Okay. The question is, the average test score for the samples above 80 is different with the population mean or not. So the question here is, if the average, the sample average is 80, is that difference with the average score of the population? So you see here, if you compare by normal eye without the test, you see 80 compared with 75. They are different, right? However, if you use the test, the statistic tools to compare, they may be not different, or they may be different or not different. I don't know. So you have to perform the test, and here you see the sample populations and the samples and the population. The sample is from the populations, so it's come from only one sample. Right? We take small samples, the average of small sample compared to the average of entire populations. So it's come from only one population. It's not in this case we take the sample from one population. So we will use the equation I show you in the screen. We will see in another case that we will compare the mean of two different samples. Okay. Now, we will use t-test or z-test here.
Just take
Why?
because the size of the sample is larger than 30.
Yeah, it's larger than 30. Here we don't know the standard deviation of the population, but we know we have the big sample size, which is 30, 40, bigger than 30. So we use that test, and yeah, let's calculate the Z here. So what is the result? Take the Excel and calculate it. What is the result? Tell me, what is the result of that test? That value?
Uh, 3.16.
3.16.
3.6.
3.16 as well.
Yeah.
Okay. So we go to another examples, and we will show you how to match with the Z score. Okay. In another examples, we need to determine if girls on average score higher than 600 in the exam. Knowing that the standard deviation for girl score is 100, we collect the data of 20 girls by using random samples and record the marks. The alpha value is 0.05. So you see the score of 20 girls here. Okay. So push that when you use, and recalculate the values. So what is 600 here? What's 600 stand for?
In the average score of my entire school.
Yeah, it's average of the population. Okay. The standard deviation is 100. The sample size is 20. How about the average of the sample? So and what is the result? Do you t-test or z-test?
Use a t-test.
T-test
T-test. Why?
because the sample size is smaller than 30, so it is considered a small sample.
Okay, so what is the value? What is the value of t?
How we can decide
How we can?
the mean of sample.
Yeah, the mean of samples. As you see in the right side, you see the score of 21. Right? So you calculate the mean.
Can you zoom slightly? The number is quite small. I couldn't see.
Okay. Mm-hmm.
But they value equal 1.83.
1.83.
83.
Okay. So what is the degree of freedom? You know the degree of freedom. What is the degree of freedom here? How many? So, the degree of freedom is equal the number of observation minus 1 and minus 1. So what is the degree of freedom?
19.
19.
19.
Okay. And the alpha equal 0.05. I stop the, I show you another website. You type convert T value to P. So in this case, you have two possibilities. You could use T table to check the T start. So you have T score. Now to check the T table, you have T start values, and then you will compare the T with T start. Or you have the second way is to check to convert the to convert the t value into p values. So you type in the Google, convert t value to p, and you click on this web. Type please. Convert t score or convert t value to p. Find it. Now tell me, you find the website or not yet?
Not yet. I found.
Huh?
I found the website.
Okay, you found the website and then you see in my screen. T-score, you type 1.83 and you calculate. DF is degree of freedom. And we have 20 observations. In the rule of statistics, the degree of freedom will equal a number of observations, a number of groups, it will be group after. Number of observations, a number of groups minus 1. So you have DF here equal 19. 20 minus 1 equal to 19. Next on the significant level. So as I give you the alpha equal 0.05, right? Next one tail or two tails hypothesis. What do you think? It's one tail or two tails, and explain. One tail or two tails. I show you again the here. So you see, we need to determine if girls on average score higher than 600. The question is this.
I think it's one tail
Why one tail?
because it's on side of the moon.
Okay, it's one side of 600. So it is higher than 600. Or the question could be lower than 600. Or it could be different with 600. If the question is higher or lower than 600, so we already determine the directions, right? The direction of the question is lower or higher than 600. So it is one tail. In another case, if the question is the average score difference with 600, so it is two tails, right? It depends on the questions, the content of the questions. You will determine it's one tail or two tails, and in this case, one tail. Okay. So you click on one tails in the website, and you press calculate. What is the result? What is the p value? Give me the number.
0.04.
Okay. 0.04. This is 0.04. Sorry. So you have the 0.04 is smaller than 0.05. Right. So you
Chị đang
accept or you reject the zero hypothesis.
cô tất đi bật lại cũng không thay đổi đâu.
Null hypothesis.
Reject the null hypothesis. Anyone have other answers? The value is smaller than 0.05. You agree to reject the null hypothesis, or we accept the null hypothesis?
I read the non-hypothesis.
Okay, we reject the null hypothesis. Sorry, this part I think a lot of you already studied in the bachelor. So if some of you haven't known about that, I will explain more details. Okay? So because pay attention in this case. When we think is 0.05, and if you have the p-value smaller than 0.05, you reject the null hypothesis. Okay? Reject the null hypothesis. It means that the average score of 20 guns is higher than 600. With the risk of error is 5%. So we have right here, right? We look at against our test. So see, we have some values smaller than 600, like 510, 530, 590, 490, and 510. So you have several values that are smaller than 60. In our conclusion, we said the average score of 20 given guns is higher than 600. But remember, with the risk of 5%, it means that we still have some risks in our conclusions. Okay? It not means that 100% of 20 given guns in our samples have the average score higher than 600. You still see some. Because here in this case, you check the alpha values equal 0.5. So please come back to the website and you check with the alpha values equal 0.01. To see what is the p-value. What is the p-value?
0.04.
Okay, 0.04 again. But in this case, what is the conclusion? What is the conclusion?
The p-value is bigger than 1.1, 1.0. I know, 1.01.
Yeah, bigger than 0.01, and you accept or reject an hypothesis?
We accept this.
We accept the non-hypothesis. Okay. So it means that it's not the average load of the sample is not higher than 600. Okay, so pay attention. It depends on the alpha values. In this case, we reuse the alpha value, and we have only 1% of risk. When you take the values of alpha is equal 0.01, so you reduce the risk from 5 to 1%. In this case, the conclusion is different, right? It's not higher the secret. So when you analyze the charts, if you got a very low p values, it means that they have really high confidence. It is very good if you have alpha smaller than 0.001. It means that 0.1%. In this case, it's very good because you have very low risk of error. In this case, you have two different conclusions with two alpha values. It means that the data is not it's different 5%, but it's much. So in this case, it's better if you the values of larger samples to have more precise conclusions to ask the sample size. Not 20, it could be 50 or 100. You will have better observations and better conclusions. So that's why in the experiment, we always have to do the repetition. Okay, when you did experiment, we did the repetition, right? We did the repetitions, and you will have better results, better conclusions if you have more repetitions. And we have two kind of repetitions. It is the technical repetitions and biological verifications. So technical replication means that, for example, we grow the plants, and in each condition, example, we grow 10 plants or 20 plants. So 10 or 20 plants here is technical replications. Or when we do qPCR experiments, in qPCR, if some you know, when we do the qPCR, always each time we have to repeat the reactions 3 times. So 3 times here called technical replications. And in this case, the sample size 20 here, we consider it is technical replications. We also have the biological replication. Biological replication means that you repeat totally the experiment in a different period. For example, this week you do the experiment. In the next 2 weeks or next week, you repeat exactly the same the procedures of the experiment. So we also require to do the at least 3 biological replications. When you publish the data, you always have to say that you repeat 3 times biological replications and how many times technical replication. It depends on the experiments. 10 times, 20 times, it depends. But at least 3 times biological replications to have really strong conclusions. Okay. In this case, the barrier between two conclusions is quite small. So it could be different. With 600, it could be higher than 600, or it could be not higher than 600. It depends on the alpha value that you type. So my advice is that in this case, you should enlarge the sample size. Okay, if you enlarge sample size, you may have a better conclusion. All right. So we have another possibility in this case is checking the t table. If you don't convert the t value to p values by using the website, you check the t table. You have the t table. Okay. T table. See the T table in my slide.
Yes.
Okay, so the degree of freedom here is 19. Okay, 9 here. Look at this row. And we have those set that we use one tail, sorry. And the values, alpha values of one tail is 0.05 here, right? So you make a cross in the column and the row. And you have the values here. Right? If we have the value of 1%, so it is 2.5. If we take the value of 5%, it is 1.7. So if percent, it is the t start. T start is 2.5, right? Yeah, it's 2.5. So we come back with our value. The t square that you calculate before is 1.83, right? It's 1.83, and compare with the 2.5, smaller than 2.5, right? So if the t start smaller than t squared in the table, If it's smaller, you accept the null hypothesis. If it's bigger, you reject the null hypothesis and you accept the alternative hypothesis. Okay. Please pay attention here. Because it is reversed with a clear P. In a clear P, if your P value is smaller than 0.05, you reject the null hypothesis. But with T values compared with the T tables, if it's smaller than the value from T tables, you accept the null hypothesis. Right. So it is inverse. Pay attention with the p-value. Okay. So when we look at the table here, you cross the row and the columns from the T degree of freedoms and the T the alpha one tail or two tails. By crossing, you will find the T value. Các bạn có nhìn thấy cái table của cô nhỉ? Sao có bạn Hà Nhung lại bảo không nhìn thấy?
Em có thấy quá.
Có cái table đấy mà. Okay, so understand. If the T's value smaller than T from the table, you accept the null hypothesis, reject the T values. 0.278, which is bigger than 0.05. So you accept the null hypothesis because it's bigger than 0.05. You accept the null hypothesis. It means that the score, the average score between girls and boys are not different. Okay. The question here they asked if the average score of girls and boys are different or not. So when you calculate the p-values are bigger than 0.05, you accept the null hypothesis. It means that they are not different. Okay, calculate exactly the same. However, now you have two samples, not sample as before. You have two samples, and you repeat the calculations. So you accept the H0s in this case. We continue with t-test. T-test. Variance is unknown and small sample size. And population is normal distribute. Okay, so the requirement for t-test and z-test are normal distributions. Variance is unknown, small sample size, and normal distribute. Okay, three requirements for t-test. You will see the examples. Here is the equation for t values. It is the same with z values. We reflect only the standard deviation of sample by standard deviation of populations. The equation is the same. So you see an example. The average test score for entire school is equal 75. So you have the average of the entire school is 75. Standard deviation of the samples of 9 students. 9 students, it means that the number, the sample size is 9. The standard deviation is 10, right? And now the question is, the average test score for the sample is above 80, differ with the population mean or not. So now they take a sample, small sample size with the number of observation is 9. And they ask you if the average score of these 9 samples above 80 differ with the average score of entire school, which is 75 or not. You will use t-test or z-test here. T-test or z-test?
I think it's the test.
Yeah, it's t-test because you have small sample size, right? Now you make an hypothesis. 8 years, the mean of the samples differ equal 75, equal the mean of populations. And H1 is mean of the sample differ with the mean of populations. So I just write in short, but when you do the exam, you have to write in full length the hypothesis. Here I just make a short. And the alpha equal 5%. I can give alpha equal 1% or 0.1%. But in this case, the alpha is 5%. Now you calculate the t-start, compare with t-squared, and give the conclusion. Please calculate it. Is that okay? So what is the values?
The t value is 1.5.
1.5, and you check from the t table. What's the value from t table?
The value from t table is 1.86.
All of you have the same answers?
Yes.
Okay, so let me check again. T tables. T tables. Degree of freedom is how many?
It's 8.
8, and the alpha 0.05. And what is the t values you said? Okay, in this case, you use 1 tail or 2 tails first.
I think it should be 2 tail
Yeah.
because this is different. It's not higher or smaller.
Okay, it's 2 tails. And what is the t? What is our t values? T squared? What is t squared? T squared from tables. Check again the tables, please.
The table is 1.86.
1.86.
Because the DF value is 8 and we checking the
No, but that is one tail. You mean two tail is different to the two tail one. Is you should this it should be 2.3. So
two tail, right?
Yeah, it's 2.3 because it's two tails. It's not one tails. It is two tails, so it's 2.3.
Okay.
Okay. Agree? So you have the T start is your the 1.5, and you have T squared 2.3. So T start smaller than T grid. You accept or reject the null hypothesis?
We accept the non-hypothesis.
Okay, you accept the null hypothesis. It means that the mean of the samples of nine students is not different with the mean of the populations. Okay, so even it is 80, it's not different with 75. You see, when you apply the test, it's not like you think sometimes. Okay. So the conclusions accept A0. Right? Next one is choose sample t-test. There are different types of t-tests as you can see in the screen. The independent sample t-test. Okay, I will send you the tables. So you have t-tests. There are different types of t-tests. The independent sample t-test, it means you compare the mean of two groups. For example, the group 1 with the drug treatments and the group 2 is control. Okay. So you compare two means of two different groups without any relationship. The number 3, one sample t-test check for mean of single groups against known means. So we just do before in the examples. Mean of the samples against known mean. Right? Mean of sample is 80, again the known mean of population is 75. So it belongs to the category 3. One sample t-test test the mean of single groups against known mean. Right? And you have last case. A pair sample t-test compare mean from the same groups but at different times. So for example, the effect of drugs after 6 months versus the pre-treatments of the same populations. So what is the difference between the category 1 and category 2? In the category 1, you take two different group of patients. Group 1, you treat with drugs, and group 2 without taking drugs. However, in the category 2, you take the same groups, but you compare, for example, the amount, the concentration of glucose in a blood sample of the patient. So you like to see an effect of new drugs to treat the diabetic patients. You take a group of patients and then you measure the concentration of glucose before the treatment and several months after treatment. In this case, we call it is pair sample t-test. Okay, pair. And first one is independent sample t-test. The last one is on sample t-test. Okay. This is the equation to calculate to do the independent sample t-test. Independent sample t-test. And you have hypothesis, the non-hypothesis, and the alternative hypothesis at 1. In the at 0, there's no statistic difference between the mean of two groups. And the alternative hypothesis at 1, it means that there's statistical difference between the mean of two groups. And you have equations. This example you see very often in the research study. In the research, you compare two samples, and the sample size is quite small. So you use t-test, independent sample t-test. Okay, this is the equations, and you see an example here. Leaf width is different between plants grown under set and full sun conditions. So H1 is the groups ones, which is plants grown under set conditions, and H2 is the plants grown under full sun conditions. I will check the equation here for you. Okay, so please calculate the T in this case. You could take a few minute breaks, or you continue and we stop soon. Okay, please do the experiment. Yeah. Do the exercise. Alright. Put the arrows at the end, and then you tie average, and then you use the tool average in Excel. You can help you to calculate it, and so the average, the first case is 49.2, and the second case is 31.67. Okay, this one is easy. Next one, you calculate the in order to calculate the variance of sample 1 and variance of sample 2 in the equations. You have to calculate the h of sample minus the mean of the populations. You will see in the slide. You calculate step by step. So you have h minus average of the sample 1. H minus average of sample 2. You calculate step by step using Excel, and then you calculate the variance of sample 1 by power of 2 of each standard deviation you calculate before. So you have variance. And then you apply in the equation I showed you in the slide. You have the final result is 5.897. Okay. You look up the T tables to have the T crit. Let's check again. If the degree of freedom is 28 and alpha is 0.05. Okay, so you have the T crit is 2.048. Okay, so T crit 2.048. You compare the T start with the T crit. T start bigger than T crit, so you accept or you reject the null hypothesis. You accept or reject the null hypothesis?
Reject the null hypothesis and accept the
H in H1.
H1.
Okay. So it means that the leaf of plants grown under shades and full sun conditions are different. Right? Okay. So your conclusion, they are different. However, there is really important point. The condition to apply the t-test. You don't know the variance of the samples. You have the small sample size. And the last condition is data must follow normal distributions. For t-test and z-test as well, the data must follow normal distributions. And here, from beginning until now, we haven't checked this. We apply directly t-test or z-test because we consider that they follow the normal distributions. Okay. However, you have to check it. If the data doesn't follow the normal distributions, you have to use another test. I will show you later. Now, how to check if the data follow the normal distributions? See in the screen. You already integrate the Excel start in the Excel, right? Yes.
Yes.
Okay. Excel start. Yeah. Okay. You open the Excel file already, right? So you see in the screen, you see the add-ins. You see add-ins?
Yes.
Yes.
Okay, click on this. You see real statistics.
Yes.
Okay, data analysis tools. So you can see a table. Follow it. You see the table. Click on the column heading include with data because you add the columns, the heading at the beginning. So you click on that. In the options, click on the descriptive statistics, Shapiro-Wilk, box plus with outliers. Okay. Yes, you follow me?
Yes. Okay.
Okay, you select the output range. Select, depend on you. You select your own. wherever you want. And then you click OK. So you see? Do you see anything? Tell me if you can do or not.
Okay, I'm done.
Okay, good. So you see, you have first discrete statistics, sample 1, H1, sample 2, H2. It helps you to calculate the mean, standard error, median, standard deviation, sample variance, etc. So it shows you a lot of things, the maximum and minimums, some number of observation, etc. Then, in the Shapiro-Wilk test, you have to pay attention on that. You see, H1, they have you to choose if alpha equals 0.05, the data follow the normal distribution or not. You see here, normal, yes and yes. Okay. In the second case as well, they use another test, the Pearson test, and they check with alpha equals 0.05 if the data follow the normal distribution or not. So in this case, it's good because the two samples all follow the normal distributions. If someone doesn't follow the normal distributions, they will write here no. Okay. So this step will help you to see if the data follow the normal distribution or not. Next one. It also shows you the outliers. None and none as well. Why I talk about outliers? Because when you collect your data from the experiment, sometimes you could get the outliers, and the outlier will affect strongly in the result. You have to remove the outliers. Okay. So in that case, if you do the experiment and you see some value which is much higher or much lower than the normal value of the samples, you keep the value or you remove it? Tell me. If you see some strain values which is much higher or much lower than the average values, normally you remove the value or you keep the value?
I think that remove for statistic and represent in the plot.
You remove it?
Yes.
Okay, you remove it. Someone else.
I think we should remove it.
Okay, we should remove it. We have to remove. Otherwise, it will affect the result, and sometimes it will change totally the conclusions. If in the case you have a small sample population, sample size. If you have small sample size and if you keep the outlier values, it may change totally the conclusions. In the case you have big sample size, it may be okay, But in some case, if you have small sample size, it will affect the conclusions. So you have to remove the outliers, and by using this test, these tools, it help you to show if you have outlier or not, and if some value is outlier, it will show you. Before, when I give the data for use, I add some outliers, but now I correct it, I remove it, so you don't see the outlier. You see H1 and H2, none outliers. But before I add it, if you add, you just try it. If you add some really high values in your data, it will show you. Let's do another example. I copy the data and I change some things. You see, if we could observe something different. Example, this one, I move to the 80. This one, 90, for example. This 70 as well. Okay, so we just check again. What is this? You see, I change only 3 values in our data set, and you see, to check the normalities of the data, the H1, yes, it still follows the normal distribution. However, the H2, no. You see here? No. So in this case, you cannot apply the t-test for this sample. Again, with the outliers, I add 2 big values. In H1, in the sample 1, you don't have outliers. However, in sample 2, you have 2 outliers, which is 70 and 80. So when you do the analysis, you have to remove these 2 values. If you remove these 2 values, you check again the data, if it follows the normal distribution or not, and I think it will follow because we just do before. So if we remove it, it will become yes and yes here. So you can using t-test. Okay. It shows you also the box plots, the maximum value, the minimum values, and some outlier here. This as well, the 2 outlier. Clear?
Yes.
You're okay, right? So remember always when you receive any data from my example or from your experiment, you have to check if your data follows the normal distribution or not. If it follows the normal distribution, you will choose the parametric test, t-test, z-test, or ANOVA. If it doesn't follow the normal distribution, you have to use the Kurzskopf-Wallis or Mann-Whitney or chi-square. I will show you later. Okay, this is really important. I'm pretty sure that just a little bit the pupil checking the data before they apply the test. So sometimes you might use the wrong test. Okay. Any questions? Hope you are clear.
Yes, I want to ask about the conclusion of this
Yeah.
example. So,
Yeah.
to get the full point, we will conclude that we will conclude the mean of leaf width in different condition grow.
The width of leaf grown under full sun condition and shade condition are different.
Okay, thank you.
So if they are different, and then when you calculate the means, the mean in H1 is much higher than H2. So you could say further that the leaf width of the plants grown under the condition 1 is higher than condition 2 by comparing the mean. With the rate of errors is 5%. Remember 5%. Okay, in this case we check 5%, but sometimes you could check 1% or 0.1%. It depends on you. But with a lower risk, the conclusion will have higher fidelity, higher confidence. Okay.
Yeah,
Any
thank you.
questions? Any more questions? No?
How to can I ask, is the outlier if there are a number like you just said before, like 7 and 80, how to remove it? I'm not really clear about that.
You remove directly from the data set.
Just remove it?
Yeah, you
Like-
remove it. You don't calculate it in the mean value.
Yeah. And okay, just delete it. Okay.
Okay, you delete it.
Okay, okay.
Anything else? T-test you will use very often in the experiment. So you should practice it frequently. I show you the tool in Excel to analyze to using T-test. I think maybe you know that already, but just show you. So you see, sorry, I will come back to the Excel file. So you could use Excel, you use SPSS, you could use the GraphPad. You know GraphPad? Some of you know?
No.
No, okay.
Yes.
So, some of you use GraphPad before, not yet? GraphPad. Prism.
Yes, I use it for the bachelor thesis.
Okay, the prisms. So you might, maybe when I have time, I will show you. Prism is the tool to analyze the results perform the statistic test, and also to draw a graph. It is really nice tool to draw graph. Much nicer than Excel. You should install it and learn how to use it. Because it's the professional tool to draw graph. It integrates a lot of things inside, and using the graph part, you will have much nicer photographs, the figures than Excel. If you don't use R, you could use graph part. So I show you how to use the t-test tool in the Excel. Look at the screen. You go to data, go to data analysis, and you have t-test here. Pair two sample for mean, two sample assuming equivalence, and two sample assuming unequivalence. So we choose two sample assuming equivalence. You select the data first, the second data. Hypothesis mean different. In this case, for the H0, you give hypothesis that two sample are not different. So you put 0 here. Label, because you have labels in the first rows. So you click on label. The alpha, you can set 0.51 or 5 or 0.01, depend on you. Here I set 0.05, and you select the output range. Okay, select the output range wherever you want. Select it, and there you are. Okay. So it has those. Calculate everything. You don't have to calculate by hand. Here you have mean H1 and H2. You have variance in 2K observations 15 and 15. You have the hypothesis mean no difference between two groups for H0. Degree of confidence N1 plus N2 and minus 2. So you have 28. T-star. It helps you to calculate the T-star value. It's the same value you obtained before, right? 5.89. Right. It also helps you to check the table. So you have T grid 2 tails, 2.05. You compare these two values. So you have T star is bigger than T grid. So you reject the S0 and you accept the S1. It means that the leaf width two conditions are different. You also can, based on the p-value, if you don't use t-value, you could use the p-values. And here you see the p-values for two tails. It's 2.4 multiplied by 10 to the power of minus 6. So it's really low. This value smaller than 0.05 or 0.01 as well. 0.1 as well. So this value is very small, much smaller than 0.001. So you conclude you accept the H1 and you reject the H0. So by using T star or by using P, they give you the same conclusion. Right? In the exams, if you have T-test, I will ask you to calculate by hand. You could use okay. You calculate by hand. You don't use the tools as I show you here. Calculate by hands using the equation I show you, and give me the result. However, when you finish the exams in the professional work, you could use the tools. Okay.
So can we use to the test?
You what?
Can we bring TC?
No. no.
So we to learn by heart the population formula.
Yeah. It's not difficult.
We can still use a calculator, right?
Yeah, you calculators. You use the T table or Z table I will give you. You have to remember the equations. Just for 2 times midterm and final exams. And then in the professional life, you can use the tools. But in order to help you to understand how the equation work, how the test work, what is the mean of the different parameters in the equations.
But
How can we decide the normal distribution?
Okay, you
Assume
okay, you are allowed to use the Excel to check the normal distribution. Okay. Any questions?
Excuse me, can you explain me again about the equation of z-test with the 2 different sample?
Tại sao người ta phải trải qua cái nguy cơ của nó?
I think you will see against with Dr. Van Angst for that, I think. TS, maybe. Okay, this is the equation for 2 sample. Z-test. You have different between sample means and different between population mean. Sample size, the population standard deviations.
So this is in the case of 2 different populations.
Yeah, the 2 populations, and two sample from 2 populations.
Okay, I see.
I think you may see against a little bit with the first part. This side. Okay, so we back to the Excel. I give another examples. Group 1, group 2. We use the Excel, and you compare the T start with the T critical, or you use the P. There are 2 possibilities for you to read the conclusions. Compare the T or check P. Okay. So a little bit come back with the one tail or two tails? It depends on the hypothesis. If in the hypothesis state the direction of the difference, for example, you say it higher or it lower, so it means it's one tail, higher or lower. You state directly in the hypothesis, so you will use one tail. For example, female will score significantly higher than male on an IQ test. So you said that it's not higher. You direct the direction, you point the directions is higher. So this one is one tail. Then two tails, it means that in the hypothesis, you don't say the directions. You only say, for example, there will be no significant difference. Okay? In the IQ test between male and female. It could be lower or could be higher if the H0 is the reject. And H1 is accept. So they are different only. And then you next, if they are different, you base on the average value of the two sample to know which one is higher or which one is lower. Okay. So one tail or two tails. We in the parametric test we have the ANOVA. We go to T-test and Z-test already, and now we have ANOVA. But ANOVA is too long for now. So I introduce a little bit about ANOVA. Then we will practice with ANOVA in the next lectures. Okay. I have to do something for tomorrow's morning. So I think tomorrow morning you will not have lectures. We will replace by another day. Okay. We don't have lecture for tomorrow mornings. Next week is okay. We have 3 lectures for next week. And this week we stop today, and I will find another day for tomorrow. Reflect the day tomorrow. Sao thế? Hàng này thích đi học à? Okay. So we continue ANOVA. First is one-way ANOVA. This is the test to analyze the variance. So before for T-test or Z-test, we compare the mean. Okay. And ANOVA is to compare the variance. We have one-way ANOVA and two-way ANOVAs. For one-way ANOVAs, it analyzes the variance and allows us to compare several groups of observations. The several groups here are independent. Okay. So it allows you to to analyze the variance of several samples. For t-test or z-test, you compare two samples, right? Two samples. And in ANOVA, it allows you to compare several samples, higher than two. If you have higher than two samples, you use ANOVA. And you compare the variance. The second condition for ANOVA is different groups are independent. Remember, it's independent. And the third condition is they follow the normal distributions. Okay, so check the data if they follow the normal distribution or not. You see, feed. This is the examples. Feed for chickens. You see, how many? You have 3 levels of feed. Feed A, feed B, and feed C, and you have chickens. The eggs of chickens are shown in the table. So look at this. Do you have any comments when you look at the table? Three group of chickens receive 3 different feed, 3 different food, and the number of eggs laid by chickens are given in the tables. So what is the comment? What is your comment? Tell me.
The sample size different.
Huh? The sample size, okay? Sample size are different. What else? The X number, the same or different? Just based on this. Before you perform the test, you think different or the same?
It's different between groups.
It's different from group A to B. So there's something maybe different. The number of X may be different between A to B and to C, right? The number of observation is different as well. Okay, so based on the opinions, do you think that at the beginning the number of the observation are different like that already, or why it have these problems? you have 2, 4, 6, 8, 10, 10, 10, and 12 observation in 3 cases. So at the beginnings, if you design the experiment, you will select the unequal observation like this, or you set at the beginning the equal numbers. If you design the experiment,
I would choose the unequal number.
okay, you will choose the equal number.
Yes.
So what happened here? Maybe what? Yeah, maybe some two chickens from A and B die. Right? So what is strategies? For example, you would like to collect 15 data from each level of treatments. You would like to, at the end, you have 15 observations. What can you do at the beginning?
Choose a sample size larger than what we want
Okay.
to, let's say,
Normally, we always, especially for something that is alive, for animal or for plants, we choose sample size which is bigger than we expected. Just to avoid some unfavorable condition or some health problems and they die. Okay. Always we use the bigger sample than we want. And in this case, it is because some chicken die. So you can calculate the mean from A, B, and C. You have these values. Okay, at the beginning, the N could be bigger than 12 for each treatment. And the sum of the observation is bigger than 30. It could be 40, 50, but then because of something die, some animal dies. So it reduces the sample size. How long is the experiment? Now you need to prepare samples in advance and very carefully to avoid some unfavorable condition for our experiment. Okay. For ANOVA, it's important to have more than 30 samples, so you have big samples. Okay. What is the best fit? The question for us, the question that we need to answer is what is the bad fit? We tried three level fit, and we want to check what is the best. Okay, so we could use the t-test for each fit, each 2 fits, and then we compare the mean. If we use the if we compare 2 fits for each, so you will have how many t-tests? How many t-tests? Three. Okay, you compare A with B, A with C, and B with C. So you have 3 t-tests. In order to avoid using a lot of repeating tests, you could use ANOVA in this case. So ANOVA actually is the reflex of t-test, but we increase the groups Okay. Here you have the factors. There are two kinds of factors. Is control factors and uncontrolled factors. And in this case, we would like to see the effect of the different factors in our observations. For control factor in these examples, what is control factors? In this example, what is control factors? We're studying the feed for chickens. What is control factors? Tell me.
Control factor is regular
Feed, okay. It treat kind of feed. What is uncontrolled factors?
eggs. The amount of eggs.
Eggs, okay. What else?
Number of chickens.
Number of chickens. So what factor will affect number of chicken alive?
The condition, the health of chicken.
The health of chicken. Okay, something else. So what factor will affect health?
In the living condition of the chickens.
The living
Into-
conditions.
Yes.
Mm.
The medication.
Okay, the living conditions. For example, the temperature, the humidity, the life intensity, for example. So those are the uncontrolled factors. Why we talk about uncontrolled factor? Because we will study the uncontrolled factors that affect our treatment. Okay, so in the experiment, we only study one factor, which is feed level, and is control factors. The environment factors like health status of the chickens, the height of chicken, the variety of chickens, and the temperature, the humidity, etc. So those are the uncontrolled factors. Okay. If we have big effect of control factors and small effect of uncontrolled factors. So what can you say about the effect of feeds? If we have very big effect of control factors and small effect of uncontrolled factors, what can you say about the effect of feed? The effect of feed on the number of eggs. What is the effect?
The fish may increase the number or increase or decrease the number of
Input.
if the uncontrolled factor is not is small.
The control factors have much more effect than the uncontrolled factors. So we say we have action of fit. We have the big effect of it on the number of X. Whereas the uncontrolled factors win or win not or have very small effect on the number of X. But the most important here is the effect of fit. Okay. If we have the small effect of control factors and big effect of uncontrolled factors, so we say that we don't have or we have very small action of fit on the number of X. And in the last case, we have the same effect of control and uncontrolled factors. We have to compare the effect of both, and you will have that to compare it. It is possible to quantify this variation and compare them. Of course, but it is necessary to make an hypothesis, and in H0 you have hypothesis that all level of treatment belong to the same statistical populations. And what it means? It means that three feet has the same effect on the number of X. All level of treatment belong to the same statistic population. It means that three level of feet have the same effect on the number of X. And we suppose that all the observations belong to the same population. The distribution of observation of the number of X follow normal distributions. So remember, in ANOVA, the data must follow the normal distribution. You have to check it before. So in the normal distribution, you have bell curve like this. If you draw the data, you will have the bell curve. Or you use the test, the tools to check it. So you will have different value to calculate. You calculate the mean, the total mean. Total mean will equal. Sorry, you see my slide?
Yes.
Okay, so you calculate the total mean, the big mean, equal the total of small mean divided by n. Big N. You have variance of totals. Big T is totals. And you calculate it. You have the variance of treatment as well. So in this test, you have to calculate three values. Mean, variance of totals, variance of treatments. And I show you the equation in the tables, in the slides. Okay. We also have the variance of error. And to calculate the variance of error, you have the equation here. Now, job is to calculate all the variants. Variant of arrow, variant of treatment, and variant photos. Then after finish sync calculations, I will show you how to analyze this. Okay. I will send you the slides. And during the weekend or tomorrow or the day after, you can take your time to calculate all of the variants before next week. And next week we will see together to see how about the result, and we continue to analyze the result. Okay.
Okay.
So we stop. I will send you the slide. So we take the data to calculate it. First, you check if the data follow the normal distribution or not. Then you calculate the different variants. 3 variants. Variant of treatment, variant total, variant error. Alright.
Alright.
Các bạn ngủ hết rồi à? Mình nghỉ ở đây nhá.
Vâng.
Nghỉ ở đây nhá. Xong rồi đến tuần sau sẽ gặp lại để xem các bạn tính toán thế nào. Ok, bye bye.
Chào cô ạ.
Chào cô. Bye bye.